Okay. All right. The next fun thing we're going to do is instead of plotting a bar chart, we are now going to get the coordinate data from the data set, which is plotting the longitude and latitude coordinates of each collision. So in this case, we are still going to start with the first part of the function, ggplot, same data set, data equals a crash, plus now we're going to use geom_point for our geom. So before we were using geom_bar, now we're just using a different one called geom_point. And this is going to give basically a dot for each collision. In this case, we have more than just an x-axis variable. We have an x and a y, where the x is going to correspond to the crash longitude, and the y is going to correspond to the crash latitude. So we're just going to get basically an x-y plot of those longitude, latitude coordinates. And we're not getting fancy at this point. We're just giving it the xy coordinates. Okay? So if you go ahead and plot that, you should get something that looks like this, which if you remember from the map, right, this is M14 curving up to US 23. So the coordinates look right. You know, they look like the original map that we saw from the original data query tool, okay? But this is just very basic. We just have little dots corresponding to each individual crash here and where in space it is. We don't have a map yet, but eventually I'm going to show you using ggmap how you can overlay this plot onto an actual Google map. Okay, let's play around now with some of the features. So because this is a dense data set, one thing you might want to do is look at the individual crashes with some sort of level of transparency. Sorry, there should be a comma here after the parentheses for crash latitude. What you'll do is put alpha, so that sets the transparency of the dots, outside of this parentheses. So this code here with mapping equals AES. Within the AES, you're going to have your x and y coordinates. You're going to close that parentheses, have a comma, sorry that's missing here, and then type, let's just play with one value here, 0.1. So this is going to give our dots a transparency of 0.1. Everything else is the same, and when we plot that, you can see you know, a little more clearly where the clusters actually are, right? So we have a pretty big cluster in this section, not so much in these other parts, right? And you can play around with different levels of alpha. So if you increase that, so like if I just go to R here, you can play around with like alpha equals 0.2, 0.5, and see, you know, what transparency is most informative to you. So I'm just going to do that myself real quick. I'm going to go to R and just play around with some different levels to show you how the transparencies differ. So I need a comma here. Okay. Oops. Thank you. Okay, so that's my 0.1. Now I'm just gonna scroll up and change that to 0.3. See how that looks. So it gets darker. Let's try it with 0.5. It'll get even darker. So again, you can just kind of play around with what level is most informative for you. In our case, I would say lower alpha numbers are better. So that really gives us a sense of the density in this case, right? That we can actually see more clearly because there's so many collisions happening in one space. Having that transparency gives us a little more depth to see all the different clusters. So here's a big cluster, here's a big cluster, that kind of thing. Yeah.
What's the minimum maximum number of comprehension?
I believe it's between 0 and 1. Yeah, so 1 is like full opaqueness, 0 is full transparency. Yeah. Was there another question? Yeah.
What is the alpha argument do again? Like, how is that calculated?
How is it calculated?
Or how does it work exactly?
So essentially, you're changing the transparency level of each dot. And in this case, we're not transforming a variable to vary with the transparency. We're just saying across all of the dots, make them a certain level of transparency. And then what that does for us is it shows us when we have many dots overlaid on top of another, it really shows us like where the intense clusters are. Because it's kind of hard to see, you know, if we just go back to, if we don't vary the alpha and we just have our black dots, it's a little harder to see that. So like there, you don't get as much information there about where the clusters really are. Okay. So that's a nice feature of alpha and transparency. All right, I'm going to go back to the slides now, and we're going to play with changing some other variables here with the XY coordinates. Okay, so now we're going to play around with color a little bit. And in this case, we are now not only plotting collisions in terms of the coordinates and X and Y coordinates, we're now going to include time of day as another variable to map on to our data. So because we're including another variable here as varying by color, we're going to include this code here, color equals time of day, within that AES parentheses. Okay, so it's very important in this case for it to be inside the parentheses because it's not that we're coloring all of the dots the same way. The color is going to be different depending on what hour it is. So each hour is going to get a different color, essentially, by doing it this way. If you wanted all of the dots to have one specific color, like blue, just all across the board, then you would put that outside of the AES parentheses. So you'd have comma, color equals, quote, blue, if you wanted them all to be blue. Okay. All right, so if you go ahead and do this, you should get something like this. So now we have our dots, X and Y coordinates, but they've got colors. And here we've got a legend that automatically pops up with time of day, and each different color corresponds to a different hour. Okay. So this is kind of nice because, you know, even though it's a little hard to see because they're so much overlaid here, you can kind of see that the colors do correspond to the rush hour times. So like the morning is like the greens, and then the kind of afternoon one is the blue and purple rush hour. Okay. Okay. Any questions about this type of plot, what we're doing here? Yeah.
I don't get so granular color. Yes, I just got the which day, which forward.
So yeah, that's because if you didn't change the format to a character, it's going to give you a continuous variable, which is the time zone format. So in that case, your scale will be continuous instead of discrete. Did anyone else get a continuous color palette? So that will happen if you just use the original time zone format. That's a continuous variable. The time is continuous in that case. So the colors will not be discrete colors. They'll be a continuous gradient. Okay. All right. Now we're going to play around with size and alpha at the same time. So we're still using our GM point. We're still mapping the latitude, longitude coordinates. This time, instead of coding time of day as a discrete color, we're going to code it as a discrete size. So what this is going to do is it's going to change each collision dot based on the time of day. So lower numbers are going to correspond to smaller dots, and bigger numbers are going to correspond to bigger dots in this case. We're also going to manipulate the alpha transparency. In this case, alpha is going to be outside of the AES parentheses because we want all of the dots to have the same transparency in this case. So size is within the AES because we're varying it with, the time of day variable. Alpha is outside because across all of the dots, we want them to have the same transparency. So if you do that, you'll get a plot, but it is going to give you a warning probably saying don't use the size parameter with variables that are discrete. Normally, this is true, right? You don't actually want to use this size variable with, categorical variables because it's not informative, right? You want there to be some kind of mapping in terms of size increasing and your value increasing. However, because this is time, even though it's considered a discrete variable because we reformatted it that way, the times do map onto the size in terms of magnitude, right? We have numbers going from 0 to 23, so it makes sense in our case to do that. We can ignore that warning. But typically, it is true that you want to use some kind of continuous variable if you're going to vary something with size, so it's not confusing, okay? The alpha here, again, allows us to kind of see the clusters a little better, and you can play around with the alpha level. You can make it lower if it's still hard for you to see, but essentially, we're getting information about the time of day by the size, right? So earlier in the morning is smaller, and then later in the day is bigger. Okay, just something to play around with. Okay, so we're going to do another variable, and this time we're going to manipulate it by color. So very similar to what we did with time of day, where we varied it by color. We're just going to give it a different variable here with day of the week, and in this case, color is going to be inside our AES parentheses because it is going to vary by color. So if you do that, you'll get kind of a very similar looking plot as before, but now you can see the days of the week are in our legend instead of the hours. So for instance, you can kind of group by weekdays versus weekends. So the weekend days here, kind of the green ones. Middle of the week is the pink and purple. So you can kind of get a sense of that maybe crashes are more likely to happen during the week than the weekends, but we still get some weekends too. In general, the takeaway from this data set is it doesn't matter, right? The crashes happen like no matter what on this stretch because it's so dangerous. So. Okay. So this is just another version here. So we're again manipulating a variable by color. We're just substituting the weather conditions. Make sure you type in this 2016 plus because your data set has weather conditions and a weather conditions 2016 plus, but this is the one that actually has the different weather conditions. And you can see it codes things like whether it was snowing, foggy, cloudy, clear. My takeaway from this, again, is that it doesn't really matter what the weather conditions are. Like we have a ton of crashes even on clear days, right, in this stretch of very dangerous highway. So, yeah. Yes?
Just a quick question. So if we weren't using the imported Excel file, but you had a typical R data frame with variable names without spaces or anything, you could just write out that variable name. You don't have to keep referring to AA crash, right? Once you indicate AA crash to begin with, you can just type the variable names for X, Y, and so forth. Like you don't have to refer back to the data frame object in that case.
Correct. So you're saying we don't have to say like X equals AA crash $. Yes. Mm-hmm. Yes.
So, does anybody else have problem with importing it as a CVS file and then getting a lot of missing values that turn up as a
NAs, you mean?
yeah. And you, okay,
Um,
maybe it's a more specific. It's probably more specific. It's just now you brought it up. It seems easier not to work with it as an Excel file, so I was trying to do that in advance.
Okay.
I'll ask later.
Okay.
I use Excel SX, don't use it. Things look great.
Yeah, so the format, like I said, the format for the variables is going to be slightly different if you're reading in a CSV file, where instead of using the backticks, you're going to just separate the spaces with a dot. Okay. So this is the cheat sheet that I was referring to before that gives you basically on the left here the general template for a formula to create a visualization using ggplot2. So again, it's just starting with the ggplot, giving it your data, picking a geom, giving it some mappings to give you X and Y variables. There's a couple other features here which we'll go over a little bit, but not in detail. There's lots of documentation if you're interested. For instance, you can create multiple panels with the facet function. You can control the scales of your X and Y axes, the labels of those axes with theme functions. So this is just giving you, your options basically here. Then it goes into all the different geoms that are available with ggplot2. So far we've been focusing on discrete, the discrete ones with one variable. So like the geom bar down here, and it gives you all of the different mappings that are available to play around with for that specific geom. So for instance, we played around with color and alpha and size. You can also create the bars, you can make them filled in with a different color outlining it, that kind of thing. And then the other one we've been working with is geom point, which is, where is geom point? Here. So to do our X and Y coordinates, we've been using that. That's also generally useful if you want to do a scatter plot and other types of data. And then again, it shows you all the different features here that you can play around with. One that we didn't play around with, which you're welcome to play with, is the shape of the dot. So it doesn't have to be a circle. It can be a triangle or a square. And there's like 23 different shapes that you can play around with. And I have a link to show you how to do that, how to control the different shape sizes or shape types. But essentially, the format is the same for all of these geoms, depending on what type of data you have. So for instance, we didn't really have much continuous data in this data set, but if you wanted to do something like a histogram or density plot, it shows you, exactly what kinds of arguments you need to pass it and what your options are. So this is really useful, just to give you an overall view of what your options are with creating these plots. The second page of this goes into first stat options, which we're not going to get into much today, but essentially, like if you thought about our bar chart that we started with in the beginning where we plotted the number of collisions by month, it defaults to just a summary of how many collisions go into each bin, but you can change what's actually plotted with this stat function. So for instance, if you want to get a frequency summary or an average, that's where you control what's actually being plotted if you don't want just a simple count. The scales feature, so again, this is something you add on after you've created all your mappings and played around with your visual features. You can change the labels of the scale, you can change the breaks, you can change whether they're discrete or continuous, that kind of thing. With the labels here, you can control like what the labels actually say. So giving it a text string for your title, your X and Y axes, that kind of thing. themes, so far we've been using the gray theme, so that's kind of the default where the background is gray and you have these white grid lines, but you can play around with, getting rid of them completely, or just doing light grid lines. So there are lots of features to play around with. We're not going to get into all of them today, but I just wanted to show you this so you have it for reference. Yeah.
It's not clear to me is this first letter that they're using, like EH or plus these other parts. Can you explain that?
Yeah, so basically that is the letter here, it's basically just assuming you've already done the code to say ggplot data. So this part, they're just kind of doing a shortcut for that section of code with a letter. And if it makes sense for you to do it that way, you can store that code as a letter and then just kind of add on layers as you, because it is a big chunk of code. If you go through all of these layers, you do your geoms, you do your, coordinates, scales, themes, it can be a lot of code. So, these shortcuts are useful.
Yeah, Catherine, you see they're tiny, but you can see the functions right at the top of each section. That's where they define A, B, F. So it's just a way to shorten the amount of code that you're writing in one line.
Okay.
And this, I presume, this is actually working our code, right? That's on this cheat sheet, so you can actually just copy paste right from here.
Mm-hmm.
I want to mention I have this. This is a very handy cheat. I didn't know about it until I saw Audrey's slides yesterday, but I actually linked this on the materials page. You can Google it pretty quick as well, obviously, but it's right there with the materials of the slides. So I actually bookmarked this in my own browser going forward. So I think it's gonna be very handy for everybody.
Yeah, for sure. And like I said, there's so many things you can do with ggplot too. Like we don't have time to get into, most of it, but it's useful to have the resources. And honestly, I Google things all the time. If I don't know how to do something, just Googling it or looking in the documentation, it's usually pretty easy to figure out how to do what you want to do. So yeah, this is very useful. If you guys want to play around and do some more data exploration, you can try to come up with maybe your own plots with other variables that we didn't go over from the data set. So you can look at things like whether the driver was old or young, and you can do it in a couple different ways. We are a little bit limited with this data set. Like I said, we don't have a ton of continuous variables other than time, which is even there. The class is a discrete variable. So you might be kind of limited to what you can plot. But if you want to spend some time just kind of playing around with different geoms and different variables or other aesthetics, we'll maybe spend like 5 or 10 minutes, or you can take a break if you need a break doing that. Okay. Good? Okay. So I'm just going to walk you guys through this Google setup to allow you to use the ggmap tool. So the first thing you need to do is go to this website, console.cloud.google.com, and sign up for a Google Cloud Platform trial. So again, the trial is free. You get it for a year, and then you would have to keep paying for it if you wanted it beyond the year. They will not automatically bill you, so they will make sure you either want it or don't by the end of the year. So again, it's up to you if you want to do this, but it is nice to actually have the Google map as your base layer to see exactly where these collisions are happening. So essentially, once you have that account set up, you're going to, give them some billing information, give them, just some basic information about your account. And then at the top here, you're going to create a project. So up where it says Google Cloud Platform, you can call it whatever you want. I called this Data Viz Workshop, but you can call it map, whatever you want to do. And then once you create the project, you have to add a map static API service to the project. So to do that, you're going to click on the menu at the top left, and then find the APIs and services option. And then within that, you should click on library. And the library will show you all of the different API options that are available, but you should search for this one. It's called Map Static API. So once you find that, go ahead and click Enable, and this will allow you to basically import an embeddable map image. And they have a couple different options for what type of map. So we're going to be using a road map just because our collision data is on a road, but they have terrain and other different types as well with this option. Okay, so once you have done that, you have to generate an API key. So you have a very specific key that you're going to register with your ggmap package. Okay. So the way to do that is to click on this APIs and services again, and then scroll down to the credentials option there. And then within that, it's going to give you your own specific key. It's a string of letters and numbers. The one thing you do have to do that I found out is you do have to select this restrict key option under the API restrictions when you generate the API key. And then once you do that, you'll click the Map Static API is the one that's being restricted. The last step here is you have to make sure that your billing account is linked to the project that you just created. So after you have done the API key and restricted that key, if you go back to the main home page, you should see either on the left panel or on the main dashboard, either one, if you click on billing. And you kind of manage the account in there, you can make sure that your specific project, like my DataViz workshop project, is linked to your billing account. Anyone have any questions? Yeah.
Backwards.
Sure.
How do we get to the screen where I restrict the key?
So if you go to APIs and services and then click on credentials, and then it's going to give you an API key up at the top, and then at the bottom of that, here, I can go to the website.
I don't have that.
Okay, let me go to the website and show you. Okay, so if you click on APIs and services and credentials, so do you guys have this option here where you have the API key
I don't.
and you click on it? This is where the restrictions down here are, and then it shows you what the key is here. And then once you have your key, you can go back to R and register your API key with ggmap. So make sure your ggmap is loaded, either type library ggmap or click on the package in the console area. And then just type this code ggmap : register _ Google, and then key equals, in quotations, whatever your specific key is. So it's a long string. So you can just copy it from here. So if you click on your API key and then click this, it'll copy that link, and then you can paste it into that line of code. Is everyone doing okay with this so far? Anyone having issues? Yes.
I moving a little slower.
Okay,
so
no
just-
problem.
Hopefully, I won't have a question, but we'll see.
Okay. Any other issues?
Audrey, can you go back to that code for the setting the API keys?
Let me get back to the API.
So it's this line here.
Go to the APIs.
And then
APIs and services. Yeah.
Thank you.
Everyone have their keys registered? No. Are there any slides or views you guys want to see again, or
Is there any typing the?
this is in RStudio?
Oh,
So
that's
once,
in our.
yeah, so once you've generated your API key from the Google website, then if you go to RStudio and you load your ggmap package and then type this line of code here, and you're just filling in your own personal API key that you just generated, where it says set your key here
With the quotes or without?
with the quote.
I have an issue where my API is enabled, but it's not showing up under credentials.
So if you are in here, it doesn't have a green
It doesn't show
check.
up there.
Doesn't show up there at
It's
all.
not there at all. It just says no, even though when I go back into library, it says that it is. Is there a step in between that?
That portion, but now we have to go to R, and it's gone. So yeah, that's what that's supposed to
Like, sorry, you have to click create credentials.
Move that.
How many go?
Do you want to call one? Yeah, click restrict key.
That's impressive.
Just call it.
Okay, that makes a lot more sense. It's just like, wow. You just
Mouse is the last.
How do I look at
The billing. So if you go to the menu and click billing. Yeah, yours is linked, so you're good. Okay.
Okay.
Thanks.
Might be I have a triangle, orange triangle. All of you now.
Okay, so click on, I'm sorry, click on API key.
Oh, I guess that's the same thing.
So just some common issues here. So if your API key does not have the green check here, that means it's not enabled, it's not working. So just make sure that you have clicked that restrict key option, and then it should be fully enabled. Okay. Any other issues with this? Sorry, it's kind of a, yeah. Yeah, sure. So it's this line here.
The 2 colons?
Yes, it's 2 colons, ggmap : register _ Google key equals, and then you're going to fill in that with your specific API key from the Google platform website in quotes.
Oh, you don't need that, I'm sorry. You don't need that.
So for those of you who have this all set up, you can start working on our next plot here. So this is actually going to create a map of this region that we are interested in with our collision data set. So essentially the code here for this, you're going to store this code as a variable called something like AAMap. And first you're going to type get _ Google Map. And you're going to set the center of this map to be specific coordinates that correspond to this region of Ann Arbor. I just Googled, I went to Google Maps and found this area and found the coordinate of the center of this area. So that's how I found these specific values. But you could do this for any area of the world, right? You just have to find the specific coordinates of whatever map you want. So here we're setting this as the center coordinates equals C parenthesis ln, so LON, so that's the longitude coordinate. It's going to be equal to this number here, -83. And then comma latitude, so lat equals 42, and the rest of those numbers. These are just some parameters here that give you things like how far in or out you want to zoom. So I think the bigger the number is, the more you're zooming in, like towards the building level versus like the continent level, as if you go the other way. And then you can specify what the map type is. You can say map type equals, and then in single quotes, they have like a couple different options, like terrain is another option. We're using road map specifically to get the highway and roads information here. And then we're just saying we want this to be a colored map, so color equals color. Yeah.
I'm sorry, one more. Can you please go back to that ggmap key thing one more time?
Yeah, no problem.
Or if that's in your slides, is there any way you could send it to him already so we could update our slides so that we don't have to keep asking you to go back?
It may not be in my slides, so I'll just show you. That's okay. So let's see. So you wanted to see the how to create the key to begin with?
No, the GG, like in R, the R code, the ggmap : register. Okay.
You're getting an error.
I'm getting an error. It's an error in
Do you have the ggmap package loaded?
Oh, that might be what it is, because we also need to check those instead of just, okay, that I'm sure is exactly what the problem was. Thank you.
Good, okay. Yeah, so just make sure you've loaded it. So after installing it, you also have to either type this code, library ggmap, or check the box for it. Yeah. Okay. Oh yeah. Mm-hmm.
So here's a question from the chat. What kind of restrict APIs should I choose?
Just the map static API for now. So if we go here, just this one, the map static API is the one you need. Any other questions? Sorry, this is kind of a pain. Okay.
Question about the, while people are working, so we're querying the Google API here to get these maps, right?
Yeah.
Can you tell us, there's probably some restrictions on that, like we probably can't like do this a million times in a second or something like that? I mean,
Right.
I don't want to get too deep in the weeds, I just wondered if you know if there's any kind of, I think you said it's gonna expire
yes.
after a year, right?
So there are some restrictions if you don't buy like the full version. I haven't run into any issues yet, so I don't know specifically what they are, but there are some features.
Just for general use, it should be good for the time frame.
Mm-hmm.
Okay.
Mm-hmm. Yeah. Yeah, I have not looked into purchasing at all, so.
Audrey, this first step where you get an API key, right, is mandatory to use GGMap? Okay, so we're right there.
Yeah, so I mean, obviously you can still plot the coordinates like we've been doing, you just won't have the base map under it. So if you want to use this feature, you have to go through this. And I think this is kind of a recent thing, just in the past like 2 years that Google has enforced this. So yeah, it is what it is.
You can always screenshot the map.
That's true. Yeah, that's true. If you get the coordinates right, you can probably just get around it. Mm-hmm. Yeah. Okay. So now we're going to just plot some basic coordinate data like we were doing before with ggplot2. So this formula you've done many times now. So you can go ahead and either paste that in or find it if it's in your history. Just to get the basic coordinates of each crash. And the next thing we're going to do is combine these two layers, right? So it's slightly different when you combine the ggmap command and this information, because we basically are only calling a plot command once. So we're not going to do ggmap and ggplot. We're just going to do the ggmap to call the plot and then put the layer of the geonPoint stuff over it, okay? So it is going to look a little different. But here's what that code should look like. So you're going to start with calling ggmap and putting AAMap in as the map variable. There's some options here with like how the map should look. We're just going to use the normal which I think is default, but you can specify extent equals double quote normal. So after you've done that command, you're going to do a plus. So we're adding now this layer of the geonPoint. So again, we're not calling ggplot, we're just calling ggmap. But we're using the same code here to create that layer of the geonPoint. So the aesthetics of the crash longitude and latitude are the same. After you do your AES aesthetics mappings, you're going to close the parentheses, do a comma, and then specify that the data you're using here is AA crash. And remember, we're doing this because we haven't called ggplot, right? We've started with ggmap, so it doesn't know yet what the data set is. So you can do that within the mappings of geonPoint instead. Okay? And if you do that, hopefully there's no errors. You should get the map with the data overlaid onto it. Is everyone there? No. Are we getting errors or? Okay. No worries. You can just admire it. I'm just going to move forward because the formula is very similar here. It's just the one thing we've added here is alpha. So once you have the base, geonPoint information, you can play around with those features just like we were without the map beneath it, as long as you're playing with, variables that go in those mapping arguments. So in this case, I've just added alpha to get the transparency of those points on the map. Yeah.
Where's the open paren for that alpha? Right, because
In this case, it's the GM point parenthesis.
but you have two closes already.
You don't need-
Oh, sorry.
Yeah, there's an extra one there after AA crash, the second AA crash.
Oh, sorry. Sorry. So this should not be there. Yeah.
Satellite view on top of this map. That's a picture of
That's a good question. I think that might be an option. I'm not sure.
Audrey, can you repeat that?
If there's a satellite map option, yeah, I'm not sure. You can look and see if that is one of the features. Yeah. I'm not sure if it comes with the trial. It could. So another thing you could do here is just play around with the color like we were doing before. So again, your basic formula is the same. Now we're just changing the color to vary by a variable weather conditions, which should be inside the aesthetics argument because it's varying with the levels of the weather conditions. And in this case, I'm using an alpha of 0.5 also to get some transparency with that. So yeah, you can go ahead and play around with it a little bit, but essentially you're doing very similar things that we were doing before. It's just a slightly different format because we're using the GG map to plot, and so where things go is slightly different, but basically the same as before. Okay. Any questions about kind of changing these aesthetic parameters with GG map?